Then you've got to do your X. You find your ACB, you find your split your middle, you do your 4-term grouping. And you find 2 different binomials that will actually make it. So this could be, even if it looks like it's perfect square, but this middle term doesn't match up, you can still get a binomial times a binomial when you factor it. You just have to do it the long way. Okay? I just rather not do that one the long way if I can avoid it. And since it's a perfect square, boom, I'm done. Okay? That doesn't mean it's not factorable if it's not, though. It's just you have to do the work if it's not. Okay, so the last little bit I want to at least introduce is factoring by substitution. Okay. So this is also in 9.2. This is called factoring by substitution. This is the one method, if you took 308, the one method that's not of factoring that is not review. Okay. Okay. Substitution. Okay. All right. So this is when you have what's called quadratic, that's an A, quadratic, in form. Right. It's not actually a quadratic, but if it's quadratic in form, then you can go ahead and crunch the numbers the same way you would a quadratic, and you can factor it that way. Okay? If it's not quadratic in form, then you can't use this method. Okay? So when you have this method, when you have quadratic in form, you will use substitution. And specifically, I'm going to ask you to use what's called a U substitution. U just means that's the letter we're going to use. You can use any letter. You can use M or Y or anything else. But we're going to use U because that's a common letter for substitution in math. In fact, moving up, if you move into like higher in math and into a calculus cycle, U substitution, it's being consistent, is something that you will continue to see in other contexts and more complex forms. Okay? So this is how you use a U substitution. Let's say you are given this to factor. X to the 4th minus x squared minus 20. Okay? Now, is this quadratic?
Yes.
Remember, quadratic means degree 2. Second degree. Is this second degree? What's the highest exponent you see? 4. This means this is 4th degree, also known as a quartic. Okay? So it's not going to make a parabola on a graph like a quadratic or a highest degree square would. Okay? But if it is quadratic in form, then we can use the same ACB number crunching method. Here's how you do your U substitution. Write U equals whatever your middle variable is. Yeah. Now it's not. Now when I say variable, I do not include the coefficient. The coefficient here is -1, or if it was anything else, it was -3 or +8. Doesn't matter. You're just writing your middle variable. Okay. So U equals your middle variable with whatever exponents it has. Okay. Okay. Now to test if it is quadratic in form, do this: square both sides. Okay. So we're going to square that side, U squared, is equal to, put this in parentheses, x squared, and square it. And what is x squared squared? Right. Because our power rule says raising an exponent to another one, you multiply the exponents. Okay? So is this, so if we say our middle term is U, is our middle variable is U equals x squared, and then we square both sides, and what we get, is that the first thing? Yes. That's what you ask yourself. Is that the first variable? Excuse me. The first variable is the question, and it is. Okay. And so check. That means you have quadratic in form. And I'm just going to abbreviate that quadratic in form, quad in form. Okay. Okay. And if that is true, if you square both sides and you get the first variable, then this is going to be your U substitution. So put a box around it. That's the only one you need now. Yes. There you go. Okay. So U equals the middle variable. Square both sides, and if what you get matches the first variable, then you know you have quadratic in form. Put a box around the original thing. That's your U substitution. You don't need this one anymore. This was just a check to make sure that it's quadratic in form. Now, that also requires that the constant is a constant. If you've got any other variables and stuff here, it's not. Okay, this is still a constant. Constant is the constant. Okay? Unless there's a GCF. But I'm not going to give you ones with GCF. We're going to keep it simple. Okay? So, because this is quadratic in form, that means you can use substitution. So everywhere you see an x squared, replace it with a u. Because you just said u equals x squared. Okay? So, where you see x to the fourth, what will you put? Yeah, because if you put a u here, that would be x squared, or u, and then squared, which x squared squared. So yes, you are sort of using this to make your substitution as well. So if u squared is x to the fourth, that means this becomes u squared. And x to the squared becomes minus u minus 20. Okay. Now that's quadratic. Okay? We can factor that. All right? So our AC is negative 20, and our B is negative 1. Okay. So our magic pair and what's our sign pattern? 2 pluses, 2 minuses are a mix. To get a negative 20?
1 minus 2.
Yeah, 1 minus, 1 positive. Huh? So what two numbers will work?
Would it be negative 20?
Which would then have to be times 1. Did that add up to negative 1?
95 times
4? Yeah, 5 times 4. And which one's negative?
5.
Yeah. All right. So 4 times negative 5 is negative 20. 4 plus negative 5 is negative 1. Okay. So it's the same number crunching. Okay. Magic pair of numbers. Now is A equal 1? Yeah, then you're done. You don't need the second step. Okay. If A is not 1, you are not done. Okay. A is 1, so you are done. So that's your magic pair of numbers. Now you did this with u's. Yeah, u plus 4, u minus 5. Now is that the factored form? If we FOIL that, is that the factored form of the problem we were given?
In a way.
No, because it still has u, right? So now we have to substitute back.
X squared.
Everywhere you see a u, put in an x squared. X squared plus 4, x squared minus 5. Okay? So you have to substitute back. Now, do we have linear factors here once we substitute it back?
No.
No, which means we're not necessarily done yet. Remember, you're not done until all the exponents are gone, until you're linear, or until, if you have exponents, you've checked to make sure if they're prime or not. Now, on Tuesday, we're going to focus on quadratic binomials. Okay, so this looks like this, difference of squares. This is a sum of squares, so it's prime. Sum of squares aren't factorable. And this is a difference of a square, but that's not a perfect square, so that's not factorable. So you are done in this case, but sometimes you won't be. Okay? Okay? Okay, so one last substitution example to get you started. And the more you finish the homework before I see you on Tuesday, the better off you'll be. We're going to jump into quadratic binomials. But we can start with a little substitution, but I want to show you the two main type of examples you're going to see, so you can practice them yourselves. Let's do 3x minus 1 squared plus 5 times 3x minus 1 plus 6. Now that, instead of an x to the fourth and x squared, we have, well, this looks like it'll be quadratic because that's a term squared, and this is the same term not squared, and then a constant. Remember, if this is not a constant on the end, then don't worry about it, okay? So, but this looks like it'll be a quadratic term and a linear term because these things match. Yeah. This would be like saying y squared plus 5y plus 6. Okay? But so, x squared plus 5x plus 6, but instead of just this plain old x, it's this quantity. But remember, anything that's locked up in parentheses, that's a quantity. It moves together. This is a quantity squared plus 5 quantity plus 6. But that's messy to look at and factor. Okay? So, let's see if our u substitution works. We got u equals our middle variable. What is our middle variable?
5 times 3.
Just the variable.
3x.
Yeah, just 3x minus 1. We have a coefficient here. What's our quadratic coefficient? And what's our linear coefficient? 5. Those are part of our use substitution. Doesn't matter what our numbers are. Once we substitute for our variables, we're going to crunch our numbers same as we did before. All we care about is making those ugly variables look nice and clean. Okay? So we take the ugly middle variable only. Okay? So that is our middle variable, just the variable, which in this case is a quantity variable. Okay? And then square both sides.
And it does
And it does match, right? That is the first variable, Okay? So it is, and it also, just to make a note, plus the constant is okay. Plus it has a constant. Okay? A constant as the third term. Because if the third term wasn't a constant, that throws all of this out. Okay? You have to have your plus c at the end. Okay? So check, it is quadratic in form. Okay? Which means you're going to use this as your substitution. Okay? And for your u squared, you're going to put it, or for 3x minus 1 squared, you'll put in u squared. Okay? So 3x minus 1 squared becomes plus
5.
plus 5u.
Right, the coefficient's just waiting there for us, but the 3x minus 1 becomes a nice, pretty, clean u. And then our constant plus 6. Yeah.
Wait, how did you?
I know, right?
How did you know? Go back to that second step, right?
Okay, right here?
Yeah.
Okay. So, go ahead.
How did you know it was square? Or how did you know that it could work?
Because if you always take your middle variable and you say u equals that, period. Okay? So if you can square both sides, and what you get when you square this looks like this, then yes, check, we have quadratic in form. Okay? And then you go back, and where you see that just that 3x in the middle, you put a u, and for the thing squared at the beginning, you put u squared. If you're not checking your coefficients over here, but if there are coefficients, they go in front of the u. So this had a coefficient of 1 u squared. This has a coefficient of 5u. Did that clear it up? All right. So now it's just number crunching. Now we just do our ACB. AC is 1 times 6, B is 5. Sign pattern is plus plus. Okay. 2 positives that multiply to make 6 that add to make 5.
2, 3.
Yeah, 2 and 3. 6 and 5, depending on signs, positives and negatives can change to be 6 and 1, 5 and 1, 2 and 3. So always double check that. 2 times 3 is 6, 2 plus 3 is 5. Okay.
So on this one, once we write it out,
Mm-hmm.
you know, the u plus 2 and the u plus 3.
Yeah.
You know how in the last one it was to the power of 4,
Uh-huh.
and the other one was squared. This time would we just write x then, like to finish it off?
So substitute back?
Yeah.
Okay, so when you see a u here, what is u equal to?
3x. So we write that.
Yeah. So here, when instead of u plus 2, we do 3x minus 1 plus 2. U
With double print.
plus 2. Yeah, that's just yeah. But do we need these inner parentheses now?
No.
No, there's nothing. Now I can just drop them and I just simplify like terms. Yeah. And this one, a u plus 3 is 3x minus 1 plus 3. Okay. U plus 2, u plus 3.
And on, like, let's say a test or something,
Mm-hmm.
you want us to simplify it all the way?
Oh, yes.
Take
Yeah.
off the,
You substitute back, and if there's anything to simplify, this would be the final answer. Okay? You have to do the minus 1 and 2. You have to do the minus 1 and 3. And that would be the final answer. You want it in simplest terms, basically. Okay. So, like I said, you're going to see a second 9.2 homework post that's going to include some perfect square trinomials and factoring by substitution. Make a point of practicing those perfect square trinomials in the shorthand way we showed. Okay? Get used to that. It might be uncomfortable at first because it feels like memorizing formulas. But once you're comfortable with it, it makes everything more efficient, and it's really going to help later on. You're going to need that skill for later in a different way. Okay? I'll also go ahead, before I see you on Tuesday, and post the 9.3 homework, just to give you a preview of what we're working on next week. We're going to be finishing up our factoring techniques with quadratic binomials next Tuesday, and then on next Thursday, we're going to be working on solving quadratic equations, which we solve with a factoring method. All right, and look for the calendar to update as well. I'll send out an email once I'm able to get on and get all that updated. All right, have a great weekend. Oh, there's probably, I think our network's still down, so I don't think we'll have a lab today, but you're welcome to come by my office if you have any questions. Let me see if it has come up, though. Oh, I think we might be okay. I'll go ahead and go down to the lab as long as it's working, if anybody wants to come down. Be down in about 10 minutes.
Well, labs are from 12 to 1, right?
12 to 1 on Tuesdays and Thursdays, yeah. Different times on Monday, Wednesday. Yeah, we seem to be okay, so I'll be down there in 10 minutes.
There's a notes for the calculator, right?
Yes, and they're posted on my math lab too as a PDF.